Okay, so a little introduction to organic chemistry. Organic chemistry is the chemistry of carbon, and usually it's molecules that have carbon and hydrogen. The other elements that show up a lot are oxygen and nitrogen. Now, carbon is super special because it has 4 valence electrons, and so it typically forms 4 covalent bonds, and that makes it really good at forming long chains and rings of molecules. I'm going to let you guys try these. Maybe I'll do one, trying to figure out molecular formulas from a structural formula. So that just means we're counting the atoms. In this first example, I can see that there's 1, 2, 3 carbons, so it's C3. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, so I'd write 8H, or H8, and there's 1 oxygen, so I'd write O. So those are the really condensed down molecular formulas. We will also see some formulas that are a little bit less condensed down than that, where they're kind of a little bit like the structural formula, where you'll kind of group these things. So you'll write CH3, and then CH2, and then CH2, and then OH. So that's kind of a condensed structural formula. They're both right, they just give you different amounts of information. The structural formula obviously gives you the most. It shows you exactly how all of the atoms are bonded together. The condensed structural formula, gives you some sense of the structure while also being more compact, and then the molecular formula just gives you the number of each kind of atom in the molecule. So I'll let you guys try the rest and I'll post solutions. Now these molecules on the right are all the same molecule. They've just been drawn a little bit differently, and they're the same because all of the bonds are the same. This oxygen atom is bonded to 1 hydrogen, and it's bonded to this carbon, a single bond to this carbon that's on the end of this chain of 3 carbon atoms. And if you look at all these other ones, that's the same. This oxygen is bonded to that end carbon and is bonded to a hydrogen, and it's the same here. So you have to watch out. In organic, there's so many different ways to represent the same thing that you can get tripped up and maybe think you're dealing with something different. But these are all the same because all of the atoms are connected in the same way. Whereas these molecules are not all the same. This one is just like the ones above. This one is different. The oxygen is now in between 2 different carbon atoms. Instead of being bonded to an H, it's bonded to 2 different carbons. It's a different kind of molecule. And in this one, you have the oxygen bonded to an H, which is the same, but it's bonded to the middle carbon on the chain instead of the end carbon like it was in this one. So these are actually all 3 different molecules that all have the formula C3H8O. So as you can imagine, organic chemistry can get a little bit tricky. It can get a little bit complicated because with one formula, one molecular formula, I now have 3 different molecules. That also means I'm going to need 3 different names, but we'll talk about that. Okay, the main family of compounds that we are concerned with in this unit about fossil fuels are the alkanes. Alkanes are the simplest kind of organic compound. They are composed only of carbon and hydrogen, which are the hydrocarbons. That's where that name comes from. And they are fully saturated with hydrogen. You've heard that term before in terms of fat. That has the same meaning here. So all of the bonds in alkanes are single bonds. So they're all single bonds between all the carbons and all single bonds between all the hydrogens. And as a result, there ends up being a nice little mathematical formula that can help you predict the formula of every alkane if you know how many carbons it has. So the first member of the alkane family of compounds, or the alkane class of compounds, has 1 carbon atom, and it's called methane. And so to figure out the number of hydrogens, how do we use this formula, CnH2n plus 2? Well, if n is 1, then I plug in 2 times 1, that's n, plus 2. So 2 times 1 is 2, plus 2 is 4. So if carbon is 1, then H is 4, okay? Now I think I actually just did part 2. Sorry about that. If we just draw it and do our dot structures, we're bringing our dot structures back in here. We know that H has 1, and they're going to share those pairs of electrons. And when we do that, that gives carbon that full octet. There's the 4 bonds that I know carbon's going to form, and every H just forms the 1 bond that it always forms. And we can draw it a little bit more neatly and concisely if we just do this. So we could have figured out that CH4 is an alkane. It's all single bonds, only hydrogen and carbon. It's the simplest alkane. So this is the simplest organic molecule out there, methane. But I can also do it with this formula, okay? And this formula gets more useful as the molecules get bigger. So for example, if I go here, this was CH4. If I want to jump all the way down to, let's say, one with 4 in it, if carbon is 4, then I have to do 2 times 4, which is 8, plus 2, which is 10. So the hydrogens will be 10. I'm going to let you guys try the rest. I'll post the solutions. Okay, the last bit becomes naming. There's a lot of complexity in organic compounds, and therefore there's got to be a lot of detail in our names. So the first and most important thing to think about in an organic compound is what is the longest continuous chain of carbon atoms. So in the first example, there was 1. The word for 1 carbon atom in organic chemistry is meth. And because it's an alkane, that's why it was called methane. That one that I did here has 4 carbons. Assuming those 4 carbons are all in a straight chain, the word for 4 carbons, or the prefix for 4 carbons, is bute. So meth, eth, prop, bute. Those 4 are a little bit tricky to remember. After that, it gets a little easier. 5 is pent, 6 hex, 7 hept, 8 oct. You may have heard of octane, as in petrol, as in gasoline. So that's related to an alkane that has 8 carbons in it. Now, to try to remember metheth prop bute, you can remember that my elephant poops bananas. Obviously, that makes perfect sense, but it will help you remember MEPB, meth, eth, prop, bute. Okay, so if I want to name this alkane, the one that we figured out up above, C4H10, it's called butane. So bute tells me 4, and ane tells me it's an alkane, all single bonds between carbons and hydrogens. I'll let you guys try the rest. Okay, when we start out with alkanes, there's only one way to draw them. This is methane. These are the next 2, which you're going to try to name above. There's only one way to draw these 3 alkanes. But once we get to butane, that one with C4H10, there's actually 2 different ways to draw butane. There's the straight chain version, which is just called butane. And there's this version, which is 3 carbons in its chain, and then a branch, a carbon that branches off of the central carbon. So even though they both have this molecular formula, we actually have 2 different structures. And these 2 different structures are called isomers. They're the same in terms of their molecular formula, but they're not the same in terms of their structure. They have a different structure. So they have the same chemical formula, but different structures. Okay. So sometimes you could be asked to try to find all the different structures. So you always start with the longest chain, and then you try to come up with branches. The key thing about a branch is that it can't be on the last carbon. Like if I do this, I've really just drawn the straight chain butane again, that one on the left. I just made it have a little kink and travel upwards at the end. But I can still see that the longest chain of carbons in a row is 4. So this is not a different isomer. This is just this one over here on the left. So branches, when I try to draw isomers, I can only draw branches off of middle carbon atoms. And then I can get different carbons. So in this one, you're going to try to draw isomers of pentane. There are 3 of them. See if you can figure them out. Excuse my coughing. Okay, the last thing is trying to name. So these 2 isomers. This one, the longest chain is 4, so that is bute. it clearly is an alkane. It has all single bonds between carbon and hydrogen, so it's called butane. There's nothing else on it, so that's the name, butane. Kind of has these two parts. Okay, this one, when I do the longest chain, right, or I could do the longest chain this way. That's another way to count it. A little more confusing though, so I'll stick with it's the same, but it's more confusing. So let's do this. So 3 carbons tells me prop. All single bonds with carbon and hydrogen tells me ane. So I know that this thing is going to be called propane. But if that's all I said, then you would think that this is a 3-carbon molecule. And it has this other carbon here that we have to address. We have to include it somehow in the name. Now, the word for 1 carbon is meth. And when we have these branches, we end branches with YL, methyl. So what do we call this thing? We call it methyl propane. Notice that if you add up meth and prop, which means 1 carbon and 3 carbons, we get the 4 carbons that are in our molecule. So that's good. It's a good double check if your name could work. Now, additional to this, to get even more clear, you usually want to tell me where the methyl is. And for that, we have to think about this chain and we have to number it. So I can start on either of the ending carbons and go 1, 2, 3. It's 3 carbons long. Our methyl group is off of the 2nd carbon. So I write 2-methyl propane. That's the name of this molecule here. Now, yeah, is that super complicated? Absolutely. But it's also really informative. If I give you this name, there's no area for confusion. You would, if you saw this name and had to work backwards, you'd say prop is 3, ane means they're all single bonds, and there's 1 carbon, meth, off of number 2. Now, this doesn't say anything about hydrogen, but in organic chemistry, hydrogen is kind of a given. If you don't have enough bonds for something, fill it in with hydrogen because it's the chemistry of hydrogen and carbon compounds. And I would get that structure. Okay, so I'm going to leave the rest of this to practice, and I'll leave some solutions for you so you can check your work at the end of class. Good luck. I'll be back next class to discuss.